A very good day to Doctor and everyone. My name is Wan Weiqi with the metric number of AE190085. Today, I would like to have a presentation for the group project for the course of high voltage engineering with the course code of PEB 40403. And the title for the final technical board report is the electrical field characteristic for 275 kV high tempered glass insulator. Next, I would like to introduce my group members. First is Lim Behang with the metric number of AE190098, and second is Muhammad Arif bin Azman with a metric number of CE190131. And the third is Tan Chida with a metric number of AE190079. And the fourth is me, Wan Weiqi, and the fifth is HIONG with a metric number of AE190095. And we are from session 2, group 8.
About the abstracts of our projects. So, one OpenEHV, Sendirian Berhad is a company that emphasizes in designing the high voltage insulator, not only for the clients from different fields, but for governments. So, this company will concentrate in designing the 275 kilowatts high tempered glass overhead line insulator. So for the informations, the glass insulator for overhead line has become widespread in the last 20 years. Generally, the high voltage insulator is an electrical insulator that impedes the free flow of electrons. So the creeped distance for the insulator is the shorter distance along the insulator surface between the metal parts at each end of the insulator. Creepage distance can also be referred as leakage distance for insulator. If the surface of the insulator is clean, smooth, and well gauged, the dust particles tend to fall down. In short, the glass insulator have higher resistance to breaking as compared to ceramics, and its mechanical compressive strength is higher. Generally, glass is a good insulator for electricity due to its characteristics. So high voltage insulators are made from glass, porcelain, or composite polymers materials. Nowadays, glass insulator has become one of the most popular insulators that are widely used in power transmissions and distribution systems in numerous countries. This is due to the reason that glass acts as a good insulator since the electrons are tightly bound to each other. Hence, the electrons are not free to move around. This characteristic has disabled glass to conduct electricity. So glass insulators are contaminated by salt, fog, or dust, which increase the electrical conductivity on the surface because of equivalent salt deposit density and non-solute deposit density.
I would like to present about the general summary of this 3E project. So in this project, we aim to design an overhead line insulator prototype that is instructed by the government. So first, we need to express the problem of the inadequate or faulty overhead line insulator in the power transmission and the distribution system. Second, we need to achieve the purpose of withstanding harsh environmental conditions, prevent electrical leakage, and meet the performance requirement of the power grid. Okay, next, I would like to explain about the objective. So in this project, for the objective, we want to design the structural body for the overhead line insulator of glass material that can have a better performance than the 275 kilowatt power transmission system. Second, we want to conduct the numerical simulation and the experimental test under different conditions. Third, we want to evaluate the performance and reliability of the new insulator design under different operational and environmental conditions. Next, for the scope in this project, the length of the insulator design should not exceed 2750 mm. Second, the length of the creepage clearance of the insulator design should not exceed 4200 mm. Third, the conductor cross-sectional area is fixed as 175 mm square. Fourth, we use the FEMM software as the tool for the modeling analysis.
Technical summary of chosen concept design. The dielectric material that we use are high tempered glass, and this is tested on extra high voltage on 275 kilovolt. The suspension arrangement is used on each insulation disc is connected to each other with metal link and in the form of string. With this arrangement, later the insulation disc can be replaced easily. The insulation disc prototype is designed in smooth and rounded shape, which to distributing the electrical field more evenly as to prevent high electrical intensity accumulate on a spot. With this smooth and rounded shape design, it's also an advantage as a good cleaning, natural good cleaning. The high tempered glass insulator has high durability due to the electrical and mechanical properties will not be affected by aging, high dielectric strength, and heat resistance due to high temperature. Finite element analysis simulation software that we use for this project is FEMM, which is an open source software package for solving 2D FEA asymmetric problem in electrostatic. Why we use this? Because it easily to use and it is free and easily accessed. It provides the graphical interface that allow the design, implementation, processing, and post-processing of electromagnetic field problem. The 2D design of suspension overhead line insulator is drawn in the FEMM software, which later will be create a mesh analysis. In short, it will be analyzed in graph of voltage and field intensity can be analyzed via the XY plot of the field value.
So now we'll continue our presentations with a flowchart for overall process flow of FEA simulations of insulator prototypes. So the figure shows in the presentation slide is about the overall process flow of the FEA simulations of the prototype of the 275 kilowatts overhead line glass insulator. Generally, the overall process flow can be categorized in 4 phases, which are phase 1 until 4. Phase 1 is about the research and understanding stage, and the rating of the transmission system and the type of the overhead line insulator is proposed in this phase. Not only that, sort of comparison between the glass insulator and other types of insulator are conducted to determine the pros and cons of the glass type insulator for 275 kilowatts transmission system. Phase 2 is about the installations of the design software and simulation software. So the design software you choose to use for this project, and the prototype is called FEMM software. Each group member will review about the tutorial for each software via online platform, such as YouTube, once the software has been successfully downloaded and installed. Phase 3 is regarding to the structural design of the overhead line glass insulator. The detail of the design of the glass insulator are discussed. The final phase is about to conduct the numerical simulations of the glass insulator designed via simulation software. The simulation is proposed to evaluate the performance and the reliability of the new insulator design under different operational and environmental conditions. Preparation of final report and presentations has also been conducted in this phase. So that's all for the process flow. Thank you.
Next, I will continue the presentation for the FEA simulation results and data observation and in-brief analysis. And in this session, they have 2 conditions that is being selected from the report, which is the dry condition and the contaminated condition that being discussed in these sessions. For the first condition is a dry condition. And here shows the insulator that is being conducted under the dry condition, where there is no any rain or the precipitation that's surrounding on the aerodynamic glass plate. And next, we will create this mesh. And after creating the mesh, that we can observe the voltage and also the field intensity density graph for our insulator. From this voltage density plot, that we can see that the color is faded from the dark red to the light blue red according to the insulator shape. And after that, we can observe of the voltage line graph that via the plot of the XY graph. And we can see that according to the voltage line graph, it can show that it will gradually decrease from the 275 kV from the first unit of the insulator until the 7th unit of the insulator, which is about 13 kV, and it will gradually increase in the 8th unit of the insulator. And next, we can observe of the electric field distribution in the insulator by product of the field intensity. And for this diagram, we can observe that the classes in the insulator is being consistent at all the points. And next, in order to observe of the field intensity density line graph, then we can see of the plot of the SY. And here we will select for the magnitude of the field intensity, and we can observe that the graph is showing that the incline until the 150 mm of the length, and then it will showing the decrease the gradiary until the 7 unit of the insulator.
Yep, HIONG AE1900995. So now I'm going to explain about the result, which is regarding about the contaminant test on the 275 kilowatt of the glass insulated prototype. So this one is the model design of the contaminant test. So as we can see that there's irregular shapes on the this, which is this one. So this one is a irregular shapes that represent as a dust that accumulate on the surface of the glass disc. So this one is the model we modeled, and the next one, which is the result. So this one is the result. So at first I'll show about the voltage. So this one is a voltage graph, voltage density plot of the insulated unit. So as we can see that the voltage decrease gradually, which indicates that this insulated unit is functional as well, although the disc is acclimated with the dust. So for the next one, which is the plot of the field density, so which is we are more mentioned about. So this one is a field density of the density plot color graph. So as we compare to the dry conditions, so we can see that the distributions of E field become more uneven already due to the accumulations of a dust. So this one is become more uneven, and it become more severe at the bottom, which is near the insulator. So this is because the field intensity that's supposedly distributed evenly throughout the insulator become uneven, and smaller area in exchange become higher field intensity at certain points. So the contaminant conditions create a sharper edge, which is by the dust, and uneven inclining lines as compared to the clean conditions. This is because the accumulated dust on the surface of the glass plate create more uneven points on the glass plate, which is slightly change the structure of the insulator. So the uneven points affect the distributions of the E field, electric field, as the electrical charge have more tendency appear towards the sharp points. Hence, the field strength increased at the particular point, like this one at H, and at a particular point, like this one. So the clothing insulator is the unit that most concerned reader has been affected most, which the corona effect or breakdown might occur at a certain point of the particular, which is around here, become quite distorted of the E field strength. So this is the glass plot, which is the distant length of the insulator units compared with the E field strength. So as we can see that for the 0, which is indicated at the conductor side, so for the 100, which is indicated at the grounding side. So as we can see that the E field increased at the first unit of the insulator and then decrease again, which also will increase rebounce back at the grounding unit. So this one is a distorted E field as comparing to the dry conditions of the insulator unit.
For the conclusion from the FEA work, FEMM is used as a software to solving to the FEA of asymmetric problem in electrostatic. Numerical simulation and experimental tested are carried out by designing insulator via AutoCAD, and FEMM to conduct the electrical stress test and simulation. The test is conduct under wet and dry condition, and grading versus with grading ring and without it. wish to identify the potential flaw. For the future suggestion work, we need to developing such a technology for high tempered glass insulator monitoring and diagnostic, so that we can get early indication of deterioration, implement real-time monitoring of electrical parameters such as leakage current or flashover.
Now I would like to continue with the safety risk assessment. So for our project, the safety risk assessment title will be the electric field characteristic for the 275 kV high temperature gas insulator under the standard switching and lining power test. So for the purpose of doing this safety risk assessment, we want to test the insulator flashover and withstanding ability under the different environment conditions. So for the experimental procedure, there's 11 steps. First, the DC input voltage supply will be connected to the single stage impulse generator and the high temperature glass insulator respectively. Second, we will use the impulse set to supply the positive and negative impulse voltage to test the circuit. Third, the voltage supply is charged to the capacitor simultaneously, and when the charging voltage is too high, the discharge condition occurs between the electrode and lead to short circuit. Thus, the short circuit will make all the capacitors connected in series. The high voltage is generated by adding the charging voltage of the capacitor. Fourth, the voltage input generator will initialize the dry and wet condition under the standard switching and lining pulse test. 5. The Wuzhen test was conducted by voltage supply of 1/50 microsecond square wave to the insulator. 6. The dry test will be conducted and the voltage increase progressively and maintain for 1 minute at power frequency. The insulator must be able to the temporary over voltage without flashover. 7. The wet test was conducted and there is no artificial running during the dry condition test. The volume control artificial run is generated by motor that will entirely cover the sample surface, so that the voltage will gradually increase until it reaches the temporary over voltage in 1 minute. And we ensure the sufficient clearance of the testing area to prevent the unnecessary flashover to the nearby equipment. 9. The output voltage is measured using the capacitor divider. 10. The specific level impulse voltage are applied to the test object and its flashover or withstanding ability is monitored. 11 step. The performance of the high temperature glass insulator was observed and recorded. Okay, that's all for the experimental procedure for the safety risk assessment.
In the code of conduct session, there are two parts that need to be discussed. For first is the test setup procedures and the second is the safety aspect. Here shows some of the test setup procedures when conducting the lightning and the switching impulse test in the HP lab. For first is the power supply is disconnected from the high voltage equipment by opening circuit breaker and isolator. And the second, the approved live flash tester is used to ensure all phases are not connected. And the third is the lifting switch is closed and all the conductors are off. While for the safety aspects, the students are not allowed to work in the high voltage lab in the exam of the lecturers or the laboratory assistant engineers. And second, the appropriate clearance must be provided to prevent unplanned or accidental flashover. And the third, the equipment in the high voltage lab should be well connected to earth potential.
Okay, so in conclusions, so high voltage testing is able to carry out as proposed to be conducted via the method of switching and lightning impulse test on the high temperature glass of the insulator prototype. So 275 kV or higher in voltage is planned to apply on the insulator prototype as to test the insulator flashover and withstanding ability under the different conditions, which are dry, wet, and grating wind conditions. The coordinated conditions is neglected as it is way too difficult to imitate or to achieve the real situations choose would be tough. to collect the genuine data. So thought this method is a destructive testing method. So hence the couple pair of the insulated prototype are needed to be prepared as to conduct the experiment and to collect the further data results. So according to our component sections, so the switching and lighting impulse tests are performed on the insulators is to investigate any possible of the AC which will corona and flash over on the insulator where dry, wet and grating rain conditions only. So contaminant is not neglected. So nevertheless, the code of conduct of this testing also attached in this proposal as a guideline to ensure the safety of the personnel and equipment. So the most crucial key is to conduct the testing under the accompany of the professionals such as the lecturer and supervisor. So lastly, so need to the procedure and the safety aspects is needed to be read and comprehend before carrying out the testing as to minimize the error which also prevent any several accidents that could happen.
And this is a presentation from our group. Thank you.